Very good evening to Dr. Hafiza and all my fellow friends. So today I'm going to introduce you guys a UV-vis spectrophotometer model that done by our group. So first and foremost, what is spectroscopy? Spectroscopy is the interaction between electromagnetic radiation and the matter. So now let's go into our model. So first and foremost, this is our light source, and this is our monochromator, which is known as wavelength selector and sample tube. And this is our detector, PMT, photomultiplier tube. And last but not least is our signal processor and readout monitor.
Hi, first I'm going to go into a little bit of detail into the working principle of a UV visible spectrophotometer. Then later we will be talking about each of the components that make up our model. Okay, so first, the working principle, which is absorption. So if we shine a light onto our sample, some wavelengths of light will be absorbed by a sample, and some will be transmitted through. This transmitted light will be detected, or rather the absorbance of light will be detected and be displayed onto the readout device here. So this is essentially the working principle. Okay, now we're going to talk about the components of the UV visible spectrophotometer in more detail. Okay, first is the light source. Our light source here is a laser pointer, which emits light throughout the UV and visible region, but in two separate modes. So right now the visible light is turned on, which is actually white light. Okay, white light emits light throughout the visible region. We can also turn on UV light for the UV region, but it's not shown here because its intensity is quite weak. Okay, so now we're going to move on to the monochromator tube, which consists of this long tube as well as this DVD. So a monochromator consists of an entrance slit over here, an exit slit as well as a dispersing device. There are two types of dispersing devices. One is the prism, and number two is the diffraction grating. So this DVD is essentially a diffraction grating. So a DVD consists of a transparent part as well as a silvery reflective part. So the part which does the dispersing is actually the transparent part. As you can see, light from the distance is being refracted into its various wavelengths. So how are we going to separate out a certain wavelength to be transmitted through, which is through the exit slit. So the exit slit, by adjusting the exit slit, we can, as well as the angle of the DVD, we can adjust the wavelength of light that's supposedly going to be transmitted through. And before we move on, I forgot about the entrance slit. And the entrance slit, its function is to only a small amount of light to pass through. We don't want too much of stray light to be entering through the tube. We need to only allow a certain wavelength of light to pass through. Okay, now move on to the sample cell, which is its function is to essentially hold the sample. Here we have a replacement of a glass tube. In actual UV spectrophotometer, it's something made of fused silica, which is actually transparent throughout the whole UV visible region. Okay, and next it will be the detector, which is this cardboard box over here. Cardboard box as well as a device over here. In actual UV spectrophotometer is called a PMT tube, a photomultiplier tube, which emits electrons for each photon that strikes the detector, and the detector sends out electrical signals to the processor and readout device. Processor and readout device essentially displays out the wavelengths into a spectrum for us to see the absorption spectrum. That is all. Thank you.